Hi, it's my great pleasure to present our MSBD 503 group project, a prediction on bank clients' term deposit subscriptions using Spark. This is the outline of today's presentation. There are 7 sections. Alright, let's get started. Section 1, Introduction. The background of the project. As we all know, among thousands of services offered by banking system, term deposits are of great significance to the banking industry. The explanation for this involves 2 main reasons. For one thing, term deposits provide an important vehicle for banks to obtain the funds necessary for issuing loans. Lending money is a core means by which banks make money. For another reason, from a larger social and economic development perspective, term deposits are able to collect idle funds and then make it possible for banks to redistribute the idle money to the individuals or industries in need. This whole money reallocation process increases the liquidity of the currency and boosts the economy. As a result, banking companies attempted to attract as many fixed deposit contracts as possible. The banking system has accumulated a lot of personal and financial information, such as age, education, marital status, salary, loans, etc. in its database. However, due to the large amount of information, they're not able to make full use of the information that leads to profit. With the rise of big data technology, now we have the tools to better utilize the data. Apache Spark provides the key. Spark is a powerful distributed querying and processing architecture. It can allow us to analyze the big data as easy as using SQL. The expectation of our project. In this project, our group expects to predict if new clients will subscribe term deposit or not by using PySpark technologies. Also, we like to compare the performance of the model in single client PySpark with the one using Spark cluster environment on Azure. The data description. We found the dataset, bank marketing dataset from the UCI website. The file named bankadditional.csv from the dataset has been chosen as our project data. We list the data features here. Section 2, Technologies. The first technology we use is RDD, which is known as Resilient Distributed Dataset. RDD allows data to be computed in parallel, which improves the efficiency of reading and processing the data. RDD increases the speed of the whole operation as well. And then is Spark SQL. Spark SQL is a module for structured data processing. We'll transform the bank marketing data, which is stored in CSV format, to a structured data frame. We'll be able to use Spark SQL to read and process the data more efficiently. Then is MLlib. MLlib contains many high-quality machine learning algorithms such as classification, decision trees, random forests, and so on. The variety of algorithms contained in MLlib can surely help us yield better results. And then is ML pipelines. ML pipeline represents a workflow which consists of a sequence of pipeline stages to be run in a specific order. And then is visualization. We used Matplotlib, Plotly, and Seaborn to analyze the correlation between whether new clients will subscribe term deposits or not and other features. And then we use cloud computing Azure. Azure is a cloud computing service offered by Microsoft. We apply PySpark cluster on Azure to the data in this project.
Introduce the data mining and analysis part of our project. Firstly, we clean the data by checking the non-values before other data analytical tasks. And then we modify the columns with dotted names by replacing dots with short lines to just avoid the problems of library conflict. During the exploration, we also found that the distribution label, the target we will predict, is imbalanced, as people who have subscribed a term deposit are much less than those who not. The solution of this problem will be given in the next section. By the observation of some attributes, we also draw a conclusion that middle-aged people, married people, and people with university degrees or high school diplomas make up the majority of clients. To do the prediction of label, we then did a feature selection to select the columns we need. By the scatter matrix, we have found that they are not highly correlated numeric variables, so we kept all of them except day and month columns, as well as contact column, since these three are all about indicating contact communication and signal use. So we got a new structure which includes bank client data, social and economic context attributes, and other attributes. Before training the model, we did feature engineering work by the techniques of estimator and transformer in Apache Spark. Categorical columns like job, education, housing, and so on are encoded by string indexer in advance to get a column of label indexes. Then the estimator of one-hot encoder estimator transformed the multiple columns to a one-hot encoded output vector column. After adding the numeric columns like age, duration, and so on, the transformer of vector assembler merged the processed vectors into a single feature vector for our later use in algorithms.
Now I will introduce the model fitting part. As mentioned in section 3, the distribution of our target label is imbalanced. In order to reduce the effect of the imbalanced dataset to the performance of our models, we will consider the class weight in model fitting and use metrics like ROC, AUC, and F1 score to measure the performance of the models instead of just focusing on the accuracy. Here are some introductions of the metrics which we will use. Informally, accuracy is the fraction of predictions our model got right. However, it doesn't work well with imbalanced dataset, so we should use precision and recall, which are two better metrics for evaluating class imbalance problems. Unfortunately, precision and recall are often in tension, so we also use F1 score, the harmonic mean of precision and recall, to evaluate our class imbalance task. We also use AUC as our metric. An ROC curve is a graph showing the performance of a classification model at all classification thresholds. This curve plots two parameters, TP rate and FP rate. AUC stands for area under the ROC curve. That is, AUC means the entire two-dimensional area underneath the entire ROC curve. Generally, the AUC getting closer to 1 means better performance of models. In this project, we have tried 4 different models in ML library in Spark to make a prediction of deposit term, logistic regression, decision tree, random forest, and GPT classifier. Here are the results of our models. Among all, GPT classifier has the best performance since it has the highest F1 score, AUC, and accuracy. Since the dataset is imbalanced and label 0 class makes up the majority, if the models predict all examples with label 0, it can get a good-looking accuracy. But this doesn't make any sense for the banks to find their potential customers for deposit term contract. Therefore, we regard the recall metric is much more important than the others because it means the percentage of predicted true customers among all customers who are willing to make deposit term contract. The recall of all models are not so satisfying, and one reason for this is our dataset is very imbalanced, so that our models cannot learn the features of data with label 1 well. That is why we try to do the resampling job. Since label 0 class makes up the majority, we do a downsampling work on label 0 class samples in the training dataset. As a result, there are 4,167 label 0 class examples and 4,916 label 1 class examples in our resampling training dataset. The performance of models trained with our resample dataset is shown in this table. GPT classifier is still the best classifier among all models. The values of recall from all models are obviously promoted, while F1 and AUC also increase a little bit, which means that resampling is an effective method to solve imbalanced dataset problems. Since that the recall can arrive 0.9196 now, the banks can find their potential customers successfully. As precision and recall both are in a contradictory relationship with each other, with the improvement of recall, the values of precision drop in the resampling case, which means that the bank will disturb some customers without willing for making deposit term contract. Although recall is the most important metric in our task, how to trade off the recall and precision is a further improvement for us in the future.
This is Li Jingjie. I'm going to talk about the Azure part. We want to know how the performance is if we run the entire process, including data cleansing, model training and model testing, on a Spark cluster and try to compare between running on a cluster and running on a single client. Since each of us got a $100 budget on Azure in this course, we choose Azure as our cloud service. The process is quite straightforward. We use our Azure account to set up a virtual machine. As the budget is limited, we choose a dual-core CPU and 8 GB memory configuration for our virtual machine, which is very cheap. And then we install all the softwares we need for the Python and Spark cluster. In order to simulate the real environment in the industry, we also set up the Hadoop distribution file system where we store our dataset. After all the configurations are done, we can run the PySpark script in a single client as well as in a Spark cluster. The process is trivial, so let's just take a look at the result. We expect that running on cluster should be faster than running in a single client. To our surprise, all the processes running on the cluster are slower than running in a single client. We think that it is mainly caused by two reasons. First, the cluster initialization and communication took more time, and the dataset we use is too small to reflect the advantage of the cluster. So the effect is not so good in this case. Second, the cluster only contains one worker, so multiple parallel computations cannot be implemented in a cluster, which causes this consequence. If we use more workers, its performance may be better.
Conclusion. Through the class and the project, we were able to apply big data computing skills to intractable big data tasks by using Spark. Bank marketing dataset from the UCI website is a suitable dataset, and we tackled a term deposit prediction by means of the dataset and achieved the goal of our project by implementing several big data techniques, which we learned in the class. After assembling several prediction models by PySpark, we acquired the first result, which showed that GPT classifier had the best performance. Nevertheless, we noticed that the label 0 class occupied the majority in the dataset. In order to cope with the imbalanced data problem, we operated a resampling work on the dataset and solved the problem. After the resampling work, we were able to achieve a meaningful result. Finally, we ran the same models using PySpark cluster on Azure. However, we were not able to obtain a satisfying result since the size of dataset is not large enough, as well as clusters are also not enough. This accident offered us an insight. The more clusters should be utilized to make the best use of it, and it strongly increases our curiosity about big data computing. Future work. Throughout the project, we analyzed the dataset from various aspects and accomplished the prediction work. In spite of our best efforts, we have several available optimizations. As future work, we would like to show the following tasks. The data size. Our dataset is too small to reflect the advantages of big data. So if we can find a larger dataset, we will be able to highlight the strength of Spark. Prediction models. We have tried several models, but we can also apply other models to the dataset in order to improve our prediction accuracy. What's more, we can find other better ways to balance between the recall and the precision. Azure's option. In the use of Azure, we only created one walker for the Spark cluster, which led to the bad performance. Therefore, we could try to apply more walkers to the Spark cluster to get a shorter training time. Thank you very much.